In this class, let us learn about combination of capacitors. First, let us see series combination of capacitors. Consider two capacitors C1 and C2 connected in series with a battery of potential V. In series connection, the charge on each capacitor will be same. So Q1 is equal to Q2 is equal to Q. But the potential difference will be different. The total potential V will be the sum of V1 and V2. Therefore, V is equal to V1 plus V2. For a capacitor, Q is equal to CV. Therefore, V is equal to Q by C. Suppose the combination is replaced by an equivalent capacitor Cs. The charge on the capacitor will be Q for the same potential V. So, we can write V is equal to Q by Cs. And V1 is equal to Q by C1. And V2 is equal to Q by C2. So let us substitute in this equation. Q by Cs is equal to Q by C1 plus Q by C2. On cancelling Q, we get the equation 1 by Cs is equal to 1 by C1 plus 1 by C2, where Cs is the equivalent capacitance of the series combination of C1 and C2. If both are identical capacitors, C1 is equal to C2, then 1 by Cs is equal to 2 by C1. Therefore, Cs is equal to C1 by 2. For n identical capacitors in series, equivalent capacitance is equal to C1 by n. Now let us consider capacitors in parallel. Let us consider two capacitors C1 and C2 connected in parallel with a battery of potential V. In parallel combination, the potential difference across C1 and C2 will be equal to the applied potential V. Therefore, V1 is equal to V2 is equal to V. But the charge on each capacitor will be different. Q1 is the charge on C1 and Q2 is the charge on C2. So the total charge drawn from the cell Q is equal to Q1 plus Q2. For a capacitor, Q is equal to CV. And suppose the combination is replaced by an equivalent capacitor of capacitance C, so that the charge on the capacitor is Q for the same potential V. We can write Q is equal to Cp into V, and Q1 is equal to C1V, and Q2 is equal to C2V. Let us substitute in this equation. Cpv is equal to C1V plus C2V. On cancelling V, Cp is equal to C1 plus C2. If both are identical capacitors, C1 equals C2, therefore Cp equivalent capacitance Cp is equal to 2 times C1. For n identical capacitors in parallel, the equivalent capacitance will be n times C1.